In the 21st century, we have witnessed remarkable advancements in science and technology, particularly in the field of genetics. One such advancement, still in its nascent stage, is the concept of designer babies. This term, laden with both excitement and apprehension, refers to the possibility of genetically modifying embryos to select desirable traits in future children. Imagine a world where parents could choose their child's eye color, height, even intelligence. The possibilities presented by designer babies are as fascinating as they are unsettling. While the technology is not yet advanced enough to achieve all these feats, the ethical and societal implications of such possibilities are already a subject of intense debate. The prospect of designer babies compels us to confront fundamental questions about human nature, the limits of scientific intervention, and the very essence of what it means to be human. Is it ethical to tamper with the very building blocks of life, even if it means preventing debilitating diseases? What are the potential consequences, both intended and unintended, of altering the human germline? These are not merely hypothetical questions, but pressing concerns that demand careful consideration. This essay delves into the multifaceted world of designer babies, exploring the science, the promises, the perils, and the profound ethical dilemmas associated with this rapidly evolving field. It aims to provide a balanced and nuanced perspective on this complex issue, encouraging readers to engage in informed and critical thinking about the future of human evolution.
To understand the concept of designer babies, it is essential to first grasp the fundamentals of genetics, the science that governs heredity and the transmission of traits from one generation to the next. At the heart of this intricate field lies DNA, the molecule that carries our genetic blueprint. Within DNA are genes, segments of this molecule that serve as instructions for building and maintaining a living organism. These genes determine a wide range of characteristics, from our physical attributes like eye color and height to predispositions to certain diseases. The quest to understand and manipulate these genetic building blocks has led to groundbreaking technologies like in vitro fertilization or IVF. IVF involves fertilizing an egg with sperm outside the body in a laboratory setting and then implanting the resulting embryo in the uterus. While initially developed to address infertility, IVF opened the doors for Preimplantation Genetic Diagnosis or PGD. PGD allows scientists to screen embryos for specific genetic disorders before implantation. This screening process typically involves extracting a single cell from the embryo and analyzing its DNA. By identifying embryos carrying genes associated with diseases, parents and doctors can choose embryos free from these conditions for implantation. While PGD represents a significant leap in preventing genetic diseases, it also paves the way for the more controversial concept of selecting embryos based on non-medical traits, the essence of designer babies.
While PGD allows for the selection of embryos, the advent of CRISPR-Cas9 technology has ushered in an era of unprecedented precision in genetic editing. CRISPR, an acronym for Clustered Regularly Interspaced Short Palindromic Repeats, acts like a molecular scissor, enabling scientists to target and modify specific genes with remarkable accuracy. This revolutionary tool holds the potential not only to correct genetic defects but also to introduce desirable traits, blurring the lines between therapy and enhancement. Unlike previous gene editing techniques, CRISPR is faster, more affordable, and relatively simpler to use. This accessibility has fueled both excitement and concern within the scientific community and beyond. The potential applications of CRISPR are vast, ranging from developing novel disease treatments to engineering crops with enhanced nutritional value. However, its application in human embryos raises profound ethical considerations, particularly regarding unintended consequences and the potential for exacerbating social inequalities. The precision and ease of CRISPR technology bring us closer than ever to the reality of designer babies. It offers the potential to directly edit the genes of an embryo, potentially correcting genetic defects that cause diseases like cystic fibrosis or Huntington's disease. However, theoretically, the same technology could be used to enhance desirable traits like intelligence or athletic ability, raising concerns about a future where genetic engineering could create a divide between the genetically enhanced and the unenhanced.
Part 4. The Promise of Designer Babies. Eradicating Inherited Diseases. Proponents of designer baby technology argue that its potential benefits, particularly in the realm of disease prevention, are too significant to ignore. The ability to eradicate inherited diseases like cystic fibrosis, Huntington's disease, and Tay-Sachs disease, which cause immense suffering and premature death, is a compelling argument in favor of this technology. Imagine a world where these devastating diseases are relegated to the history books. This is the promise offered by designer babies. For families with a history of genetic disorders, the prospect of having healthy children free from these conditions is a beacon of hope. The emotional toll and financial burden of caring for a child with a severe genetic disorder can be overwhelming. Designer baby technology offers these families a chance to break the cycle of inherited diseases and ensure a healthier future for their children. Beyond individual families, the eradication of genetic diseases could have significant implications for public health. Resources currently allocated to treating and managing genetic disorders could be redirected towards other pressing healthcare needs. The prospect of a healthier population, freed from the burden of certain genetic diseases, is a powerful motivator for continued research and development in this field.
Part 5. Beyond Therapy. Enhancing Human Capabilities. While the ability to prevent genetic diseases is a compelling argument in favor of designer babies, the technology also raises the possibility of moving beyond therapy and into the realm of enhancement. Imagine a future where parents could select for traits like intelligence, athleticism, musical talent, or even physical attributes like eye color and height. This prospect, which seems like something out of science fiction, is rapidly becoming more plausible with advancements in genetic engineering. The ethical implications of such enhancements are complex and multifaceted. Critics argue that it could lead to a new form of genetic inequality, where the wealthy can afford to enhance their offspring, creating a divide between the genetically enhanced and the unenhanced. It raises questions about social justice, fairness, and the very definition of what it means to be human. Furthermore, the pursuit of genetic enhancement raises questions about the limits of scientific intervention. Is it ethical to tamper with the natural lottery of life and potentially create a generation of designer humans? What are the potential unintended consequences of such manipulations, both for individuals and society as a whole? These are questions that demand careful consideration as we venture into this uncharted ethical territory.
Let's begin. Today, we delve into the world of genetic engineering and the ethical dilemmas it presents, focusing on the controversial topic of designer babies. Imagine a world where we could potentially orchestrate the blueprint of human life. In this video, we will explore these questions and their societal implications in depth. Transition to video montage of DNA sequences and futuristic labs. A major concern is the potential for increased genetic inequality. If only the affluent can afford genetic enhancements for their children, it could lead to a new form of social stratification, a division between the genetically advantaged and the disadvantaged. This could result in a society further divided, where one's genetic makeup dictates their opportunities in life. Transition to images of diverse families and children. Additionally, the idea of playing God raises significant ethical concerns. Do we have the right to alter the natural course of human evolution? By choosing specific traits for our children, are we diminishing the beauty of human diversity and the unpredictability of life? Transition to video of ethical debates and panels. The prospect of designer babies also raises questions about consent. Future generations will live with the genetic choices made for them by their parents. How can we ensure that these decisions are made in the best interest of the child rather than driven by parental desires? Transition to video of children playing and learning. Moreover, the potential for unintended consequences of genetic manipulation cannot be ignored. What if these alterations result in unforeseen health issues or psychological impacts? The long-term implications for both individuals and society are still unknown and could be far-reaching. Transition to video of scientists researching and discussing. As we stand on the precipice of this uncharted ethical territory, it is crucial to engage in open, inclusive, and informed discussions. Policymakers, scientists, ethicists, and the public must work together to navigate these complex ethical landscapes. Only through collective deliberation can we hope to find a balanced path, one that embraces the potential benefits of genetic engineering while upholding human dignity. Transition to a hopeful yet contemplative music tone. Ultimately, the ethical dilemmas surrounding designer babies challenge us to reflect deeply on what it means to be human. As we continue to unravel this new frontier, we must not lose sight of the values that define our humanity. Fade out with reflective music. As we peer into the future, the possibilities of genetic engineering seem boundless. In this chapter, we will explore these potential advancements and their implications for humanity. Transition to video montage of futuristic cities and advanced laboratories. Imagine a world where genetic engineering has not only eradicated inherited diseases, but also extended human lifespan and enhanced our physical and cognitive capabilities. Transition to images of healthy elderly people and children excelling in activities. One of the most exciting prospects is the potential to cure currently incurable diseases. With advancements in CRISPR and other gene editing technologies, we can envision a future where conditions like Alzheimer's, cancer, and heart disease become relics of the past. The transition to video of scientists working with CRISPR technology. Furthermore, genetic engineering could revolutionize the field of regenerative medicine. Imagine regrowing damaged tissues and organs, or even growing new organs from a patient's own cells. This could transform organ transplantation and the way we recover from injuries. Transition to video of lab-grown organs and tissue engineering. Beyond healthcare, genetic engineering holds the promise of enhancing human capabilities. Enhanced intelligence, physical strength, and even emotional resilience could become a reality. This begs the question, how far should we go in altering our natural state? Transition to video of people engaging in high-performance activities. The field of agriculture also stands to benefit immensely. Genetically modified crops can be engineered to withstand extreme weather conditions, pests, and diseases, ensuring food security for a growing global population. Transition to video of lush, resilient crops in diverse environments. However, these advancements come with significant ethical, social, and political challenges. As genetic engineering becomes more sophisticated, we must maintain a delicate balance between innovation and ethical responsibility. Transition to video of global discussions and policy meetings. International collaboration and regulation will be crucial to ensure that genetic engineering is used for the greater good. Policies must be put in place to prevent misuse and ensure equitable access to these technologies. Transition to video of international summits and agreements. Public engagement and education will also play a vital role. As citizens, we must stay informed and participate in the conversation to shape the future of genetic engineering responsibly. Transition to video of community discussions and educational seminars. In conclusion, the future of genetic engineering holds immense promise for improving human health, enhancing our capabilities, and ensuring food security. However, it also requires us to proceed with caution, guided by ethical considerations and a commitment to the well-being of all humankind. Transition to a hopeful, yet contemplative music tone. As we stand at the cusp of this new era, let us embrace the possibilities while remaining vigilant stewards of the profound power we now possess. Together, we can shape a future that honors both our scientific prowess and our shared humanity. Fade out with reflective music.